Hello, everyone. I'm GP, and with me, I have Ryan. There we go. So I'm a technical manager for the Cyber Center. We work on data analysis and analytical platform in order to detect threat, mostly in the federal government, but also helping CI sectors. So I'll introduce the Dickinson Center for Cybersecurity a little bit. So we're the national CCERT. We're helping like Canadian infrastructures. We are handling over 2,000 cyber incident case every year. We're also responsible for second level monitoring for the federal government of Canada's systems and infrastructure. So we're in charge of helping detect threats on close to 1 million endpoints, a number of network gateways, and also all of the cloud infrastructure that the government of Canada is using. So we're to talk about a tool which is called Assemblyline. It's a system that's been in development for a long time in the CCCS, and it started from basically a lot of folks like you guys are reverse engineering teams getting the same samples over and over again from our analyst teams and not having a triage systems in between. So Assemblyline was kind of born to help our reverse engineering team and also help the analysts get some more information about the files that they were finding in an automated fashion. So the keyword is really automated. It is a system that was open source first in 2017, so like almost 10 years ago. And we since went through a major refactor of the system in 2020. So now version 4 of Assemblyline is a pretty mature system. We really try to integrate the best tools from open source, the communities, people like you guys, into a system that will be able to scale to large environment and basically benefit from all of those tools, but in a framework. So you can see Assemblyline as a one-stop shop for like any enterprise, which will help to coordinate all the binary analysis that are being collected. So our analytical platform in CCCS is mostly collecting telemetry, and telemetry goes into databases and Spark and other systems like that. But databases are not a great place for binary content. So all the binaries that is being collected actually ends up into the system, which is Assemblyline. So the file comes from a number of sources that can be email gateways, it can be web, internet gateways, EDR products, and also supporting analysts and forensic teams that are getting binaries from other places or when they are performing analysis. So that is millions of files every day for the government of Canada, so the system has to scale. Assemblyline also integrates like a number of signature formats, so like Yara, Circa, Sigma. It will support those very well. It let you manage those signatures within the system. It also integrates a number of commercial products, so antivirus, sandbox, so anything that you actually might want to integrate, because this is an open source system. You're able to connect it to the environment that is specific to your organization, or also to automate certain tasks that maybe there isn't something to handle at the time that it's coming. And Assemblyline is going to take all of this, and it's also going to include like a number of different services, which are Python modules for the most case, but that they can wrap other language. These modules are either wrap of open source tools. They are also custom modules that we're developing. They can be config extractors. They can be anything that you want. And Assemblyline will use those modules to do the analysis. What it's going to do is recursively analyze each file. So what I mean is it's going to go very deep, much deeper than other products in extracting all of the content that it's able to. And then different services will pick up on what they know and what they can handle and provide an analysis. So today is going to be mostly a demo, which Ryan will go over. But you'll see things like the report, the scoring that we do, the heuristics, and the tagging, the searching. And what the output you'll get out of this is, one, you get all the files that your enterprise is getting will all be found into a single system. So it's good for searching. But it's also going to be a safe place. So if you want to exchange file, the Assemblyline will inherit the files and enable your analyst to download the file in a safe format, and then you can move them to your analysis environment and render them to their original format. Three key things that Assemblyline will give you are alerts. So if you're trying to triage and find threats on your network, it will generate alerts. It has a very strong REST API, so you're able to do automation using the REST API, and it's very good at extracting indicators of compromise. So we actually use this in production in our environment to dynamically block like IPs, URLs, domains that we're seeing coming in through phishing, like emails, and we're blocking them from the analysis that Assemblyline is doing in near real time on our gateways. That helps mitigate a lot of the spam, the phishing that the users are getting, preventing when they click ultimately on those. There's a good chance they're going to be blocked already on GC network. So quick overview of the stack. So Assemblyline is cloud native. It works on Kubernetes, also works on Docker. It leverages S3, Elastic for database, Redis for message passing, and Unicorn for UI. And then really, it's a platform that you can develop easily, very quickly, new modules for new threats that commercial is not detecting at the time. So without further ado, we'll go straight to the demo.
All right, so right now we have Assemblyline deployed on VM, and this is a much smaller version of Assemblyline. It's just using Docker. So as JP mentioned, you can either scale this up to a much bigger cluster using Kubernetes, but if you're just running a small test environment, using Docker is fine. So when you sign into Assemblyline, the landing page that you'll arrive to is the submit page, and from the submit page, you have the option of uploading a binary file into the system. We have tabs for either submitting a URL or submitting a hash. And what we've found is that a lot of people, like in the community, like especially in research, they'll find a lot of hashes, and those hashes typically correspond with going to Malware Bazaar or going to VirusTotal to want to pull the file because they are actually going to embed the file in that article or in that document. So what we've added is convenience methods in the UI. So the UI is able to detect the type of string that you're passing forward to it. And depending on how the system is configured, it will actually go out and fetch the file from that remote source and submit it into the system. And as part of that, it'll include some metadata to track where did that file originally come from, and as well as what classification that file should fall under when it actually goes through the system. The options tab kind of gives you an overview of all the services that you're allowed to run as a user. And there are some properties that I won't necessarily go into here, but you're allowed to configure the service or each individual service depending on how you want to. By default, as service developers, we kind of set what we think is a good standard out of the box. But we understand that there should be a level of flexibility for users or for analysts if they need to kind of deviate from our defaults. So as a good overview of the system, there is a dashboard that we generate. So as I think it's available for both administrators and standard users, they can kind of get a good overview of the system. So you would have an idea of like how many submissions are going through the system at a time. And you would also be able to see the number of services and how many instances of that service might be running at a given point in time. as JP kind of mentioned, the services that are currently in the system, they kind of key off of certain file types, and the file types aren't necessarily based on, let's say, the file extension. Assemblyline has its own file identification process that it will use, so we'll use things like the magic. If the magic fails, for instance, and we aren't able to determine a type, then we fall back on other things like Yara rules, as an example. So we'll go through 2 samples that we found recently that we thought that were interesting to kind of outline. So in this particular, so in any submission, you can kind of look at the report view, which is basically meant to be a very high level report of the kind of analysis that Assemblyline performed. So at the very top, you'll get a verdict from the system to indicate what it thought it was. You can see here that you'll have general information about the submission metadata, essentially, as well as the root file that was submitted, and you'll get things like the hashes and things like the entropy graph as well. But you'll see there are heuristics. Heuristics are essentially important properties that a service deemed to bring forward to the system. And its importance, more or less, is measured based on how malicious that property might be. So services can assign a score of, let's say, 1,000 points to deem it very malicious, or it can deem it as low as 0 to just say it's informational, or somewhere in between to kind of identify some level of suspiciousness. From here, you'll be able to see certain things like IOCs that were extracted, as well as at what level of maliciousness that IOC was kind of detected at. And then at the very bottom of the page, you'll get things like the file tree as well. So to kind of go more into depth about this particular submission, we'll start at the root file. And in the root file here, we do have an antivirus service that we run, not particularly on this system. On another system, we pulled these samples from. What we found is that the AV actually didn't detect anything initially, and it was more or less because when you look at the actual contents of the file, well, to me, I'm not a reverse engineer, but to me, this doesn't really mean much. But with talking to JP says, well, this is clearly obfuscated. So we have ways of analyzing files or viewing the actual raw content of the files within Assemblyline that we use called the file viewer. And we've actually spent a lot of time on the hex viewer in particular to kind of provide it as a tool for reverse engineers so that it kind of enhances their workflow rather than them having to pull the file out of the system and drag it into their own kind of hex editor environment. So we know the fact that, for instance, this particular file or batch file is obfuscated. So we do have a service that kind of specializes around batch obfuscation, and its job is to basically go through lines of that batch script and deobfuscate it as best as it can. And at the very end, it will basically drop a file to basically be reanalyzed back in the system. So as JP mentioned, the workflow of Assemblyline when you provide a submission is it's very recursive. If a service decides to drop a file, it dropped that file for a particular reason. And so it goes through the set of services to be then reanalyzed again. So we can see that here, that in this batch file, or this deobfuscated batch file. So here we actually do have an antivirus hit, but the antivirus isn't very assertive on the fact of what the verdict was. So in this case, it deemed it very suspicious. And that might be fine, and we could have stopped there, but because we have other services that are running in the background, one thing we were able to pull out is this particular IOC. And we were able to pull it out by using a service that's called Frankenstrings. And Frankenstrings is basically there to find strings of interest to basically tag to the system so that way that we can analyze it. And what you'll notice in this particular case, it's the URI is composed of an IP address, and it ends with a URI path that kind of points to this a host.exe file. So Assemblyline has means of tasking the system to then go out and fetch for URLs. Some of the tasking is based on results from previous services to kind of say, well, if this URI is deemed malicious or even very well suspicious, maybe we should go out and fetch that URL. In this particular case, the service that we have will actually fetch the file or create the task just based on the fact that the host name was an IP address and it looks like it's downloading an executable file. So in the file tree, that would basically be this task here that we create internally. And then at the very end, we actually go out to the internet, we retrieve the file. And at this point in time, now we do have AVs that are a lot more assertive on the fact that this is malicious. And an interesting thing that we've kind of provided kind of for display purposes, but this also came in very useful for us to find samples of interest, was a thing that we call Ancestry. And Ancestry is basically a service that's meant to tell you where that file originated from relative to the submission. So based on this graph alone, you can see that at the root, we had the obfuscated batch file, we had the deobfuscated file. That file led to us extracting URI, and at the very end, we were able to actually download that URI from the internet, mostly because it was still hosted at the time. But the signature itself is more based around the fact that a PE file came from some code. So the fact that we actually downloaded the URI, or sorry, we went to a URI to actually get the exe isn't really that important for this particular signature. It could very well just be that maybe the PE was base64 encoded and just stored in that batch file. So it's nice that for us, or at least in our case, for finding samples that are kind of interesting like that, it's very easy to query in Assemblyline for something like this string, which kind of we generate on the fly internally within the system. So that way we can create signatures like this in the future. So we can flag things that AVs may not necessarily at the very beginning. So that's that particular sample. And then with this one, which is a little bit more involved, so one of the things that JP mentioned is we integrate a lot of open source tools as well as signature sets that are kind of hosted publicly on sources like GitHub. So in this particular example, we have rule hits from Yara, and we actually pull in these rules externally. So Assemblyline out of the box doesn't necessarily contain all these signatures embedded within this platform, but we do provide a configuration out of the box to say that once you deploy Assemblyline, you can go out to GitHub and fetch these rule sets and integrate them into the system. So as an example, from this rule hit, you're able to actually pivot from the service results or from the submission, and you can actually look at the signature content. And so from here, what we've kind of seen, or what the typical workflow is that you may have a Yara rule that's a little bit too broad, or it might flag things as malicious or suspicious when it shouldn't. And so a lot of analysts will kind of pivot back to the signature within the Assemblyline UI, and then kind of go through the content of the rule and kind of say like, oh, like it shouldn't be doing this. Maybe we should put in a pull request and kind of feed that back to the maintainer of that rule and to kind of correct it. As part of that, in this particular review, we do track like the performance of that rule over time, and you're also able to see like the first occurrence versus the last. You know, in terms of hits, has it been increasing over time or has it dropped suddenly? And maybe that's a reason to start going back to that rule. And so starting out with the root file. So this particular sample was an email, and it was in response to a job post. And so the sender was providing like their CV or their resume, which normally would be fine. That's kind of expected. So we do have, again, like antivirus and Yara rules that hit on the file, but ignoring those for the moment. So we have a service that's called EmlParser. EmlParser is a service that's built around an existing tool that's of the same name that's managed by the Luxembourg CERT. And we actually use this service to analyze EML files. And in this particular case, we were able to pull out the attachments for that email. So from the attachments alone, a PDF being submitted isn't necessarily that odd, but an Excel file, at least to me, is. So we were actually able to send this file, or the Outlook file, into the CAPE service, which connects to our CAPE Sandbox that we have hosted. And it was able to actually pull out these two, we were able to drop the Excel file from EmlParser to go into CAPE, and CAPE was able to pull out essentially these two files, or these two memory dumps. So one being a DLL file, which isn't all that particularly interesting, but this unknown file type, which was basically, an unknown to Assemblyline is basically something it can't detect, or it can't, or not necessarily that it can't analyze, it just doesn't know what that format is. But fortunately, we have services that do operate on any type of file type, and which was convenient for us because within Frankenstrings, it was able to actually find out that there was an embedded PE file within that blob, and we were able to extract it and then resubmit that back into the system. And because we had a PE file, I believe in this case, we were able to run 7-zip on it, and 7-zip actually came back with 2 more files. And so when we actually go through this, or this .xxx file, it actually contained a bunch of XOR data within it. So 2 DLL files, as well as a bunch of URIs in this case. And then we were able to send those back into the system, and we'd have the antivirus come back and they say, well, these particular files within the actual email content was actually Petya rated. In this case, it was ransomware, I believe. And then the same thing with Ancestry. We have a signature that's built around the idea of finding executables within a document, or within an Office document, to be specific. In this case, we were able to actually extract those URIs and try to attempt to fetch them from the internet. But at this point in time, the domain didn't exist anymore, so that's basically where we stopped. We couldn't really go any further. But we did get far enough to actually ascertain that it was a malicious file, not just stopping at the original email and just quitting there and saying okay, yeah, it's ransomware. We went in, we were able to go in further and figure out the exact files that actually triggered those Yara rules. So one thing that I will kind of go over mention is, so everything in this particular view is kind of submission oriented. So when you look at any of these files are kind of, or all of its analysis is kind of based on the submission and within its certain context. So we have something that's called the malware archive, which is meant to be a longer or more or less an indefinite store of malware samples. And its view is more centered around the file itself. So for instance, we can see that some of the verdicts from previous services are transferred into the archive, so we're able to see things like how suspicious that file is or how malicious it may be. We still include information like the file details as an example. Detections right now is still based around what you would normally see in the results, so you would see things like the heuristics that were raised and propagated up forward, and you would also see the raw service results. The tags are another thing that would get mentioned, and you would basically be able to see things like the verdict and the type of tag it is. So if you want to do any kind of filtering for, let's say, a particular domain within the sample, you'd be able to use this, and you'd be able to type in a domain, and maybe you will find 2 different tags that correspond to it. So you might find one that's dynamic and another that's static. And that will make a difference in terms of how and when it was seen. So we have relations. So this will kind of show you like your children files as well as your potential parents. You'll see that we have similar files here, but because of the limited amount of files that we actually have here, there aren't that many results. But essentially, similar files are based on fuzzy hashes that you may have. And so I believe we use like TLSH and we have SSDeep. So the system will actually do a query based on those hashes and find similar files and then include that as part of this section of the results. Yeah. So that's basically the malware archive. So I will basically go back to the slides, and I'm going to talk about Retrohunt. Now, retrohunting isn't necessarily a new concept. Like we've seen this on other systems like VirusTotal as an example. But in our particular implementation, we kind of took an inspiration from the Polish certs mQuery and UrsaDB. But we made some adjustments to kind of tailor it towards like Assemblyline and like the scale that we would want it at. So for instance, our implementation is more Kubernetes or more cloud focused. A lot of the code is written in Rust as compared to Python, more for performance. And you'll see in the notes that it's built with access control in mind. So an important thing is in Assemblyline, every piece of data is classified to some level or another. And that's a big way of how we control access of information across different users. So the same kind of rule applies when you create a new Yara rule and you want to apply it against a corpus of files. It's very possible that you only want only certain people to see the rule or the content of the rule, as well as you only want that rule to be applied to a certain set of files. So yeah, there's integration with Assemblyline. So one advantage that I see is that if you want to do this on like another platform, you would essentially have to share those files out to that third party where you may not necessarily want to. If you wanted to keep it on premise, this is kind of a good way of doing that. And as mentioned, like in the signature statistics, you are able to actually track the progress of your Yara rule over time to kind of evaluate its efficacy. So the Retrohunt interface is pretty in development at the moment. We've kind of released it just to kind of get feedback from our users. So at the very beginning, you'll be able to provide things like a description. You'll be able to define the search space. So if you only wanted to work on like the live data versus the archive, maybe across both. And then you're also able to provide how long should that rule exist in the system for. It's possible you may want to have it live indefinitely, in which case you would provide 0, but otherwise you can set like a time limit on when that rule should actually be there. And so when you actually go into the details of the Retrohunt, like after it's gone through the corpus of files, what you'll be able to find is things like the file types that rule hit against. So I know in one example, CAPE had a particularly, not necessarily false positive rule, it was just applied in the wrong context, and it would constantly hit on normal PDF files. But that would be a thing that's useful here to kind of say that if a rule is meant for, like, for instance, a PE file, then you would be able to say, like, okay, it's hitting too much on PDFs, maybe I need to adjust the rule. And you'd be able to go through those samples kind of here and kind of improve on your rule over time. That's all we have right now. I believe we have some time for a question.